Next data transfer instructions are string data transfer instruction. In this the first instruction is moves b and moves w. B for byte and w for word. Okay, as we know, we have seen in the addressing mode that there are two strings, source and destination. Source string is always stored into the DS register. Destination is always string is always stored into the ES register. The effective address of the source string is in SI and the effective address of destination string is in DI register. Okay, so you have to remember this, that source string is in DS and destination is in ES register. So this moves instruction copies a byte or word from DS to ES. Okay. Next instruction is repeat. So it is a prefix which is written before the string instruction, and this instruction repeat the loop or any instruction until the specified condition is occurred. Then loads B and loads W. So this instruction copies byte or word. So it copies a byte or word from source, that is from DS to AL register or AX register, because if it is a byte then it is stored into the AL register, if it is word then it is stored into the AX register. Next, opposite of loads is toss. So this toss instruction copies a byte from AL or AX to the destination. So we know that destination strings are stored into the DS register. So this toss instruction copies a byte or word from AL or AX to the extra segment register. Okay. Then miscellaneous data transfer instruction. In this the first instruction is exchange destination comma source. So as we know, the exchange means it exchange the contents of source with destination and destination with source. Okay, so here exchange bx comma cx, so bx ke contents is in cx and cx contents of cx is into the bx register. That is the exchange instruction. Next is LAHF, load lower byte of flag register in AH. It loads the lower byte of flag register in AH. SAHF means it opposite of this, it copy the AH register to the lower byte of flag register. Then XLAT means translate byte in AL. So it replaces the byte in the AL with a byte from a lookup table in memory. Next instructions is in and out. As we know, in the addressing modes we have seen that there is a port addressing mode, and in that there are only two instructions, that is in and out. So first instruction is in. So here the in instruction will copy the data from port to the accumulator. Okay, so there are two modes, direct and indirect. So in direct mode the port address is given in the instruction. So in direct addressing mode, the address is specified into the instruction and the contents of that port is copied into the AL or AX register depending on whether the port is 8-bit or 16-bit. So this is the direct. And in indirect port mode, the address is stored into the DX register. Okay, and that DX register is specified into the instruction. Okay, same, the out instruction is opposite of in. In out instruction copies a byte from AL or word from AX to the specified port. It is the opposite of in. So here the contents of accumulator is loaded into the port, output port, which is a 8-bit or 16-bit. If it is 8-bit, then contents is copied from AL. If it is 16-bit, then contents is copied from AX. So here also there is a direct and indirect port addressing mode. In direct, the address is given into the instruction, and in indirect the address is stored into the DX register.